Yeah, hi guys, welcome back. So we are in the almost end of the Kubernetes tool, which is used for orchestration. In the Kubernetes, we understood what is orchestration. We discussed about what is orchestration, and we discussed about Kubernetes introduction part. What is Kubernetes and what are the advantages available with the Kubernetes? And we discussed about most important part, which is Kubernetes architecture part. So what is control plane, what is worker node, what is kubectl and all that stuff. Then we have done Kubernetes cluster setup. We have done the Kubernetes cluster by using EKS guys. EKS is one of the paid service available in the AWS cloud. That is one of the most trusted way to run our applications in the Kubernetes cluster. Kubernetes cluster setup we have done. Then we discussed about pods in the Kubernetes, and we discussed about services in the Kubernetes, and we discussed about three types of services in the Kubernetes. One is cluster IP, and another one is node port, and third one is load balancer. And we discussed about namespaces in the Kubernetes. Okay, logically when you want to group the resources in the Kubernetes, then we are going for namespaces in the Kubernetes. And we discussed about Kubernetes resources guys. We discussed about Kubernetes resources, like we have seen what is the replica set in the Kubernetes. So you can create the pods manually also by using YML. If you create the pods manually, the pod lifecycle will not manage by Kubernetes. That's why we are going to use Kubernetes resources to create the pods. One of the resource we have used as of now, that is the replica set. And we have seen what is deployment in the Kubernetes. So when you go for the replica set, the advantage is it will take care of the pod lifecycle. Always it will maintain given number of the pod replicas in the cluster. If I give the replicas as a 3, always 3 pods will be maintained in the cluster. If any one pod is deleted, then it will replace that pod. Self-healing capability is available in the replica set. And when you go for deployment concept in the Kubernetes, rolling update is available and recreate option is available. Deployment strategies, rolling update and recreate strategies are available in the Kubernetes cluster. And we discussed about a concept called horizontal pod autoscaler. So when you go for the deployment, so we can configure horizontal pod autoscaler in the Kubernetes. So that horizontal pod autoscaler will scale up, scale down the pods based on the load. So we have configured that horizontal pod autoscaler, and we have seen what is blue-green deployment model, okay, which is most famous application release model for the production. So when you want to deploy your application with zero downtime to the production with less risk, okay, if you want to deliver, if you want to release latest code to the production, then in the companies, people are going to follow this blue-green deployment model. And we discussed about what is Helm chart, what is the Helm in the Kubernetes. Okay, what is Helm in the Kubernetes? Helm is a package manager in the Kubernetes cluster. So if you want to install any softwares in the cluster, then it is highly recommended to go with the Helm charts. Okay, now after this Helm chart, we discussed about what is metric server, which is used to monitor the cluster resources and provide the metrics required for the HPA. Metric server we installed by using manifest YML, and we installed by using Helm chart also. And we have seen how to set up Prometheus and Grafana. How to set up Prometheus and Grafana tools in the Kubernetes cluster. We installed Prometheus and Grafana softwares in the cluster by using Helm chart. Prometheus will monitor the cluster, will get the metrics from the cluster, will provide the data points to the Grafana. Grafana is a visualization software. It will provide the graphs and charts for the monitoring, like cluster resources, how many worker nodes are available, okay, what is the API server role, what API server is doing, how much memory utilized, how many pods are running, how much memory used by the pods, all the cluster, how many namespaces are available, in which namespace which pods are available. All the cluster resources can be monitored at one place by using this Grafana software. And we discussed about EFK stack also in the Kubernetes cluster. Okay, EFK stack, which is used to monitor logs of the application. There are three components available in the EFK stack. One is Elasticsearch, second one is FluentD, third one is Kibana. FluentD is going to collect the pods logs from all the pods. The logs will be collected by the FluentD and will give the logs, will store the logs in the Elasticsearch. Elasticsearch will maintain the volume and it will store the data. What are the logs that we are having? All the logs data will be stored into Elasticsearch. And Kibana, that is a web application. Kibana will provide the dashboard in order to monitor the logs of our application. I have given the video also where we have discussed, where I have explained about EFK stack setup in the Kubernetes cluster. So as of now, we completed these topics in our Kubernetes. So Kubernetes is one of the most important DevOps tool and lengthy DevOps tool also, because there are so many topics available in the Kubernetes software. In the entire DevOps course, Kubernetes is little confusing and little lengthy topic guys. Okay, so in the Kubernetes, as of now, we have covered these topics: orchestration, Kubernetes introduction, Kubernetes architecture, Kubernetes cluster setup, pods creation, manifest, pod manifest YML, services in the Kubernetes, three types of services: cluster IP, node port, load balancer, namespaces in the Kubernetes, replica set in the Kubernetes, deployment in the Kubernetes by using rolling update and recreate, horizontal pod autoscaler, blue-green deployment model in the Kubernetes, Helm charts in the Kubernetes, metric server in the Kubernetes, Prometheus and Grafana in the Kubernetes, Prometheus and Grafana in the Kubernetes, and EFK stack in the Kubernetes. So these are the topics that we have covered in the Kubernetes cluster. Then what are the pending topics are there in our Kubernetes cluster? Okay, what are the pending topics are there in the Kubernetes cluster? So we need to talk about one point on daemon set. Okay, so already when you go for the EFK stack, we use a daemon set internally. What is daemon set? I will explain that part. What is daemon set? And we'll talk about what is stateful set, what is a daemon set, what is stateful set, and another important thing in the Kubernetes, which is config map and secrets. Config map and secrets concept is available in the Kubernetes. Then next one, there is a topic called PV and PVC, persistent volume and persistent volume claims available in the Kubernetes for the storage purpose. In the Docker, we have seen the volumes, right? Similarly, in the Kubernetes also, volumes are available. Those volumes we can set up in the Kubernetes by using PV and PVC. And there is a topic in the Kubernetes which is called ingress controller. There is a topic called ingress controller, and probes, liveness, readiness probe and liveness probe concept is available. Readiness and liveness probe. Readiness probe and liveness probe concepts available in the Kubernetes cluster. Okay. So these are the topics that we need to discuss in the Kubernetes cluster guys. Daemon set, stateful set, config map secrets, PV and PVC, ingress controller, readiness and liveness probes. Readiness and liveness. Liveliness and readiness concepts will be available in the Kubernetes cluster. Readiness and liveness.
Sir, is that all about Prometheus and Grafana?
So again, we understood the concept what is Prometheus and Grafana, right? Again, when we are going to set up the project, we are going to use those tools for monitoring.
And persistent values.
Yeah. PV and PVC, persistent volume and persistent volume claims.
I think, sir, there is a you told yesterday, day before yesterday, like we have to create like its own
Yes.
Helm chart.
Yes, how to deploy our application by using Helm chart, custom Helm charts.
Yeah,
so as of now, we used predefined Helm charts in order to deploy our applications in the cluster, right? We should create our own Helm chart to deploy our application. That means application deployment process by using our own health charts.
So will you cover this one?
Yes, I will cover that. So I will give some chance for you guys. Let's try that. Let's do some research on that before coming to the class.
Sir, in deployment, canary deployment is there. So, like, can we discuss only like a few minutes?
Sure.
Sir, when we are deploying the canary deployment?
Canary deployment. Okay.
Yeah. So that is just I want.
Sure, sir.
Sir, your JLPT batch is started?
JRTP, yes, sir. It started morning at
JRTP?
7 a.m. Yeah, Java real time.
That is, you are doing a project right now, or you are just covering the topics?
Some Linux and AWS topics are going on now.
Okay, then when the project will come? Like, can you directly
Yes,
enroll
you can. So DevOps people can join after 2 weeks.
Okay.
You can join after 2 weeks.
How many days it will take?
2 weeks. 2 weeks.
No. After 2 weeks, the
3
project,
months.
3 months. Okay, sir.
The ChatGPT, Ashok?
So DevOps people can also take Spring Boot.
So yes, but Java knowledge is required.
I also want to take. I have like little knowledge in Java too, but I really
you can
want
join
to
for the
take
Java project
microservices.
and Spring Boot microservices.
How many days, Ashok, this Java Spring Boot microservice?
3 months. 3 months course.
Sir, do we require to have knowledge of microservices to deal with the DevOps engineer?
No.
That is for DevOps full stack folks, it is free?
No, that is different Java people, sir. That is Java course, not DevOps course.
Because I am a Java consultant.
Okay. No, it's separate course for that.
So I want to update my microservices. So you are going to handle that class also?
Yes, sir. That will be starting from 10th July at 10 a.m.
Oh, excellent. I will join them.
Yeah, sure, sir. Thank you.
Hello.
You are a good trainer.
So 10 a.m. morning 10 a.m.
9:30 a.m. 9:30 a.m. from 10th July.
Okay. Morning 9:30, right? 10th July.
Yes.
Send me that this one message.
Sure, sir. Definitely. We'll get that in the group.
Sir,
We should make that at 6 p.m. I wish.
Okay, good guys. Let's start. So let's understand what is the purpose of these resources that we are having. What are the pending topics that we have in the Kubernetes concept, so that we'll complete the syllabus of our Kubernetes. Okay. So the first one here, daemon set. Daemon set is one type of resource in the Kubernetes which is used to create the pods. Already we created the pods by using replica set, and we created the pods by using deployment also. Replica set and deployment we have already seen. We can configure this as a kind, and we can create the pods in the cluster by using these resources. Then what is the purpose of this daemon set? Okay, daemon set is a resource in the cluster. It is used to create the pods in all the worker nodes. Okay, so guys, whenever we are going to create the pods in the cluster by using any resource type, you can use any type of resource in order to create the pods. For example, there is a control plane is available, and worker node 1 is available, and worker node 2 is available. Okay, let me call this as worker node 1, and let me call this as worker node 2. So there are 2 worker nodes available in the cluster. These 2 worker nodes are managed by our control plane. Right. Now I am communicating with this control plane by using a software called kubectl, which is a command line utility in order to communicate with the Kubernetes cluster. So I am taking one machine. I'm taking one EKS host VM, that means which is used to create the Kubernetes cluster. In this EKS host VM, I have installed one software called kubectl. That is a command line utility software which is used to communicate with the Kubernetes cluster. All right. Now I want to deploy my application on the Kubernetes cluster. So by using manifest YML, we are going to create the pods on the cluster. But here, whenever we are deploying the application on the cluster, I want to create 2 pods, guys, or I want to create 3 pods. I want to create 3 pods or 4 pods. Is there any guarantee that your pods will be created? Is there, can you guess your pods will be created in which worker node? So currently I have taken 2 worker nodes. For example, I have taken 3 worker nodes here. For example, okay. So instead of 2 worker nodes, I'm taking 3 worker nodes. So if I take 3 worker nodes, is there any guarantee that in which pod will be created on the which worker node? Can you guess that point? Can you guess that point? Your pod will be created on the which worker node? Come on, guys.
No, sir, we cannot identify.
We
You
cannot.
cannot identify that. You cannot identify that. Now, I have a requirement, guys. I have a requirement. I want to create 1 pod on the each worker node. So when I am going to deploy my application in the Kubernetes cluster, I have a requirement that every pod should, every worker node, 1 pod should be created. That is my requirement. Okay, we are writing a manifest YML file. By using that manifest YML file, we are creating pods in the cluster. So when you create the pods in the cluster, there is no guarantee in which worker node, which pod will be created. That will be taken care by control plane in the Kubernetes cluster. Okay, which pod will be created on the which worker node, we don't know. That will be taken care by control plane in the Kubernetes cluster. But here now you assume that my application is running in the cluster. Okay, here 2 pods are running for my application. Here 3 pods are running for my application. Here 4 pods are running for my application. Okay, I have deployed my application in the Kubernetes cluster. For my application, pods are available. Those pods are created on the multiple worker nodes. Those pods are deployed on the multiple worker nodes. Now, for every pod, logs will be available. Okay, so for my application, there are total 10 pods available. So 3 pods are running on the first worker node, 3 pods are running on the second worker node, 4 pods are running on the third worker node. So total 10 pods available for my application. So when there are 10 pods running on the multiple worker nodes, now I need to collect the logs of all the pods. Okay, so if you are having these many pods for your application, checking the logs of your pods is becoming very, very difficult. Okay, so the customer is accessing our application, customer is facing some problem with the application. Now, how do we troubleshoot the problem in the application? By checking the logs. Which pod logs you are going to check now? How can you understand which pod logs you need to check now? Can you guess? The application failed because of which exception? That request is executed by which pod? Can you guess that point? Can you guess that point? The exception is occurred in which pod? Guys, can you guess that point, or you cannot guess that point?
You cannot.
We cannot guess that point. We cannot guess that point. So we need to check the logs of all the pods. So to check the logs of all the pods, it takes a lot of time, because total there are 10 pods available. There are 10 pods available. So manually going to each and every pod and check the logs of that pod and identify the problem is very, very difficult. So that's why what we are doing, guys, we are going to set up EFK stack in the cluster. We are going to set up the EFK stack in the cluster, which is used to monitor logs of the application. Okay, in that EFK stack, E stands for Elasticsearch, F stands for FluentD, K stands for Kibana. So now this FluentD is responsible to collect the logs of all the pods available in all the worker nodes. So FluentD, I want to deploy in the cluster. What is the responsibility of the FluentD? That FluentD is responsible to take the logs of all the pods available in all the worker nodes. Now, I need to deploy that FluentD pod. That FluentD pod should be deployed in the first worker node. It should be deployed in the second worker node. It should be deployed in the third worker node also. I want to create the pod in every worker node. That's where we are going to use a resource called daemon set. There is a resource in the Kubernetes which is called daemon set. So replica set is available, deployment is available, daemon set is available. What is this daemon set in the Kubernetes cluster? By using daemon set, we can create the pod in every worker node. If you have 2 worker nodes, then 2 pods will be created. If I have 10 worker nodes, then 10 pods will be created. You no need to specify pod replica count. It will identify, the daemon set will identify how many worker nodes are available in the cluster. There are 3 worker nodes are available. So in every worker node, 1 pod should be created. So if you have such kind of requirement to create the pod in every worker node, then you need to use a resource called daemon set resource. Are you guys able to follow me? What is the daemon set? Daemon set is used to create a pod in every worker node. Sir, in which scenario we will create a pod in every worker node? The best example, FluentD. FluentD is responsible to collect the logs available in the pods. First worker node logs we need to collect. Second worker node logs we need to collect. Third worker node logs also we need to collect. So if you have 10 worker nodes, then in every worker node, 1 pod should be created. If I have 5 worker nodes, in every worker node, 1 pod should be created. So if you have a requirement to create a copy of the pod in every worker node, then we are going to use a concept called daemon set concept. Okay, let us check in the official documentation of the Kubernetes what they are talking about daemon set in Kubernetes. Okay, let's go for official Kubernetes documentation, daemon set. Okay, can you guys please read these points? Can you guys please read these points? What is daemon set? Come on, guys. Can you guys read this? What they are talking about daemon set? Daemon set ensures that all the nodes run a copy of the pod. Daemon set ensures that all the nodes run a copy of the pod. That means in every worker node, my pod should be created. My pod should be running in the every worker node. As nodes are added to the cluster, pods are added to them. So if you add a new worker node, then in that worker node, a new pod will be added. As nodes are removed from the cluster, those pods are garbage collected. So if you add a new worker node, then a new pod will be created. If you delete worker node, then that daemon set pod will be deleted from the worker node. Deleting a daemon set will clean up all the pods are created. Some typical use cases of the daemon set. In the real time, where we are going to use this daemon set. Okay, running a cluster storage daemon. So I want you maintain a storage for the every worker node. Then in every worker node, 1 pod should be created. For that, we can use a daemon set. Running log collection daemon on every worker node. FluentD. FluentD is a pod which is used to collect the logs of all the worker nodes. So my FluentD pod should be created on every worker node. In the EFK stack, EFK, Elasticsearch, FluentD, Kibana. FluentD is responsible to collect the logs from all the worker nodes. That FluentD pod should be created in every worker node. So that is used to collect the logs from that. Okay, running a node monitoring daemon metric server. I want to run the metric server in every worker node to collect the metrics of all the worker nodes. Okay, so log collector, metric server, storage daemon, all these kind of pods will be deployed by using daemon set resource in the Kubernetes. Okay, so can you read this once again? If you have a requirement to create a pod in every worker node, then you need to go for the daemon set. So when you will go for the daemon set in the real time, I want to collect the logs of all the worker nodes. I want to monitor all the worker nodes. I want to maintain the storage for all the worker nodes. Such a kind of pods will be created by using daemon set concept in the Kubernetes. It's very simple and easy concept. So how to create a daemon set in the Kubernetes? They have given some manifest YML. Kind we are going to specify as a daemon set. Kind we are going to specify as a daemon set. So if you go to our GitHub repository, whatever that we have taken in our DevOps documents, not in the DevOps documents, in the Kubernetes manifest YMLs. Fluentd we have deployed, right? Kubernetes manifest YML files are there. So in this EFK log manifest YML is available. In this daemon set YML, Fluentd. So Fluentd pods I want to create in the cluster. So when I'm going to create the Fluentd pods in the Kubernetes cluster, what kind I have taken, guys? Fluentd pods I want to create on the cluster. So this is the image that we are using for the Fluentd pods. Okay. So whatever the image that we are using for the Fluentd pods, this is the image we are using for the Fluentd pods. How the Fluentd pods are created in the cluster? What type of resource we are using to create the Fluentd pods? What kind of resource we are using to create the Fluentd pods?
Daemon set.
Daemon set. So can you guys able to understand what is the daemon set in the Kubernetes cluster? If anyone asks you where you have used a daemon set, we have deployed Fluentd by using daemon set. Fluentd is installed in all the worker nodes. We have installed Fluentd on the cluster. Fluentd we have installed by using EFK stack. So daemon set, that is a resource in the Kubernetes cluster. Daemon set is a resource in the Kubernetes cluster which is used to create the pods in every worker node. Which is used to create the pod in every worker node. Are you guys able to follow me? Are you guys clear with the concept what is daemon set?
Sir, one quick question.
Yeah.
So you said like daemon set is used for creating a pod in the worker node, or daemon set itself is a pod?
Daemon set is a resource which is used to create the pods in the worker node. How we used replica set and deployment. Similarly, we are going to use a daemon set resource to create the pods. When you create the pods by using daemon set, what the daemon set will do? It is going to create the pod in every worker node. It will create the pod in this worker node pod will be created. In this worker node pod will be created. In this worker node pod will be created. The pods will be created in all the three worker nodes. Suppose tomorrow, if you add one more worker node, then what will happen? If you add one more worker node, then what will happen? One more pod will be created. You got my point?
So because of this one, the memory consumption is increased. You don't think that like because of that the daemon set?
No, sir. This pod will occupy very less amount of memory, right? We don't need to think about every memory when we are talking about the daemon set. One pod will be created in every worker node. So in which scenarios, what are the use cases to create the pods by using daemon set, metric server pod, log collectors, storage pods? In every worker node, my pod should be available. In that scenario, we will go for the daemon set.
Sir, what if
Okay, means
a
like
new pod
application,
is
we
created?
can't.
No. Remember that, guys. To deploy the applications, we don't use daemon set. Daemon set is not for our application deployment. You got my point?
To
It is
distribute the
confusing.
pods.
Application deployment we are going to do by using a resource type called deployment type. Deployment is available to deploy the application. Replica set is available, deployment is available to deploy the applications. What kind of pods we will create by using daemon set? I have my Python application. Can I deploy my Python application by using daemon set? Is it recommended? Come on,
No,
guys.
no,
Is it
sir.
recommended to deploy my Python application by using daemon set?
No,
Not
sir.
really.
It's
No.
not recommended. What type of applications we will deploy by using daemon set? Log collector,
Kind of
metric
monitoring.
server, storage pods, we will deploy by using daemon set. Are you getting my point?
So
Are you
can we
clear what is
create?
daemon set?
Can we
Oh,
create?
only log collectors. Okay.
For every worker node, one log collector is sufficient. No? If you have two worker nodes, in every worker node, one log collector pod. Fluentd pod will be created on the each worker node. First worker node, one pod. Second worker node, one pod will be created. That's it.
Sir, after creation of everything, again we need to create one more worker node. So
then yes, it will copy that. That is what they are saying in the point, right? In the official documentation, if you see, the moment when you add, as nodes are added to the cluster, if you add one more worker node to the cluster, one more daemon set pod will be added to that automatically. Control plane will take care of it.
So it is by default.
By default, you no need to do anything.
So if I don't require, that means
you can't stop it. Daemon set default behavior in every worker node, it will create it.
Okay, sir. Okay.
Oh, inside the pod we have a daemon set, right?
No, sir. Daemon set is a resource which is used to create kind. We are going to specify kind as a daemon set, sir. What is the meaning of kind in the manifest YML?
It is a resource.
Resources.
Which is used to create the pods. The kind you can specify as a replica set. You can specify the kind as a deployment. Now we are specifying the kind as a daemon set. So what is the meaning of kind is a daemon set? It is a resource which is used to create the pods.
So like namespace.
Are you getting my point? Are you clear, guys?
Sir, copying the pod data, we are using daemon set.
మనకి ప్రతి వర్కర్ నోడ్ లో ఒక పాడ్ క్రియేట్ చేయాలి దానికి daemon set, not for copy. In every worker node, my pod should be created in every worker node. For that we will use the daemon set. Guys, could you please read this point? Daemon set will ensure a copy of the pod will be added to all the nodes in the cluster. In every worker node, my pod should be created. So if you have such a requirement, then we will create those pods by using daemon set. Daemon set will make sure in every worker node the pod will be added. After creating the pods by using daemon set, if you add one more worker node to the cluster, then the daemon set pod will be created to the new worker node also. That will be taken care by our control plane. So what kind of pods we will create by using daemon set? Storage pods, log collector pods, metric server, monitoring pods. So that thing we are going to deploy by using daemon set. Normal applications we don't deploy by using daemon set. Normal application like Java, Python, .NET, these application pods we don't create by using daemon set. One of the best example for the daemon set is fluentd pods. We are creating fluentd pods in the Kubernetes cluster by using daemon set. Why? Because fluentd should be created on the every worker node. What is the responsibility of the fluentd? Fluentd is responsible to collect the logs from all the worker nodes. You got it? Still,
And does that pod has a container as well? No.
Sorry?
Does that pod has a container? No container, right?
Pod means inside the pod container will be available.
So inside the container, what will be
Fluentd,
available?
Fluentd is one application only that we are deploying as a pod. It's not our application. It's not our normal project.
Fluentd inside that container, we have a fluentd.
Yes, correct. Fluentd is one application that is developed by someone. That fluentd application we are deploying in the cluster as a pod. Inside the pod container, inside the container,
Oh,
fluentd
got it.
application will be available.
Got it. Yep,
Got it.
makes sense.
Fine, guys. So we understood what is daemon set. So what is the
Sir,
example
one-
for the daemon set?
one last-
Fluentd pods we are deploying by using daemon set in the cluster. Next one, stateful set is available. Okay. Next one, there is a resource in the Kubernetes which is called stateful set. Guys, here when we are deploying applications, right, by using containerization, we discussed about one topic called stateful containers and stateless containers. What is the topic we discussed, guys? Stateless containers and stateful containers. So what is the difference between stateless containers and stateful containers? What is the difference between stateless containers and stateful containers? Can anyone speak out?
The state is maintained and is connected to the database like MySQL or
stateless containers nothing
MongoDB.
but no storage. Stateful containers means storage will be available. Am I right? If the container is not maintaining the data after container is recreated, then that is called stateless container. Persistence will not be available. Data will be lost. If your container is deleted and recreated, whatever the data is available in the container, we are going to lose that data. Such kind of containers are called as stateless containers. Now, in the real time, database is available. So if I delete the database container, if I lose the data, will client accept it? Will client accept it if we lose the data in the database? Whenever I delete the pod, whenever I delete the database container and recreate the database container, if we lose the data, client will accept that or client will not accept that?
Will not accept, sir.
Client will not accept. So what we need to do for the database container now? We need to maintain a storage for the container. So database containers we need to maintain as stateful container. That means even after deleting also, we should not lose the data. Data should be available permanently. So stateful containers and stateless containers concept is available. So in the Docker, we will create the containers directly. But in the Kubernetes, it is called stateless pods, stateful pods. So in the Docker, we are calling them as stateless containers and stateful containers. When it comes to the Kubernetes, we are going to call them as stateless pods and stateful pods. Stateless pods nothing but no storage will be available. Stateful pods nothing but storage will be available. So when you want to create your pods with some storage, when you want to make your application as a stateful application with some stable storage, then you will create such kind of pods by using stateful set. Okay, so generally when you create the pods by using replica set, daemon set, okay, and deployment, those pods are by default stateless pods only. I want to create my pods with some storage. I want to maintain my pods as a stateful pod. I want to make my application as a stateful application. So if you want to create your pods with statefulness, then you need to use a resource called stateful set resource. When you are going to use stateful set to create the resources in the Kubernetes, we need to attach some storage for those resources. To attach storage for the resources, to attach storage for the pods in the Kubernetes, we have persistent volume, and persistent volume claims will be available. When you go for a Docker volume concept is available. So when we are creating a container in the Docker, by default that container is a stateless container. So that means we will lose the data. If you want to make your container as a stateful container, then you need to attach a Docker volume for the container. Similarly, in the Kubernetes, stateless pods and stateful pods concept is available. By default, your pod is a stateless. When the pod is deleted, we will lose the data of that pod. But in the real time, I don't want to lose the data of my pod. I want to make my pod as a stateful pod. If I want to make my pod as a stateful pod, such a kind of pods will be created by using stateful set in the Kubernetes. When we are creating the pods by using stateful set, we need to attach some storage classes for that pod. To attach the storage classes for the pod, we are going to use a concept called PV and PVC. PV stands for persistent volume. PVC stands for persistent volume claim. Are you clear with my point? Daemon set.
What does that?
Daemon set
that storage
that is used to create a pod in each worker node. Daemon set is used to create the pod in the each worker node. What is the purpose of stateful set? Create stateful applications. To create the stateful applications in the Kubernetes, I want to create my pod as a stateful pod. That means even if the pod is deleted, my data should not be deleted. For that, we are going to use stateful set. So when you want to create the stateful applications, then persistent volumes are required. Storage will be provided by PV and PVC. Persistent volume claim concepts will be available when you want to attach some storage for the pods that you are creating. Are you clear with these three topics? Theoretically, we are talking what is a daemon set, what is a stateful set, what is PV and PVC. Daemon set is a resource in the Kubernetes which is used to create a pod in the each worker node. One of the example, FluentD. One of the example, log collector. Okay.
What does that storage contains?
Storage
what
means
information?
Storage means data.
What information does it contain?
Whatever you store, database, you will store some data in the database, right? Whatever the data you are storing, the same data it will maintain.
Okay, we are creating the separate pods for it, for the database.
Those pods requires storage. You attended Docker volume concept, no? What we have done in the Docker volume? We deployed MySQL database in the Docker as a container, right? You attended Docker classes, right?
Yes.
In the Docker, I have deployed MySQL database as a container. When I delete the MySQL container, then I lost data, whatever I have stored. So if I don't want to lose the data in the database, I need to attach a volume for the container so that in that volume data will be stored. Same thing in the Kubernetes also, I am going to create a database pods by using stateful set. For the database data, I want to store the database data outside of the pod. So even the pod is deleted also, I should not lose my data. So when I want to attach some storage for the pod, then I'm going to use PV and PVC for that, which will provide storage for the pods. So with this PV and PVC, we can make our pod as a stateful pod. Stateful pod, nothing but after pod is deleted also, our data will be available. We can access our data. Generally, for the database deployments, we are going to use stateful set concept. For database deployment, we are going to use stateful set concept. Okay. Next one, we have config map and secrets. Okay. There is a concept called config map and secrets in the Kubernetes to supply environment variables. Basically, DB credentials, DB properties, DB credentials. So when I am deploying my application in the Kubernetes, I need to pass the database credentials. So instead of hard coding the database credentials in the application, I want to separate my application code and database properties. That's where to make our application loosely coupled with the environment properties, we are going to use a concept called config map and secrets concept. Just theoretically we are introducing, practically we will implement that. In the tomorrow session we will work on that part. So I'm just telling you what are the topics are there and what is the purpose of those topics. Config map and secret. What is the meaning of config map and secret in the Kubernetes? To supply environment variables to the pods. So my application will be available, my database will be available. Application should communicate with the database. I should not hard code the database properties in the source code of the application. So I want to supply environment variables to the application pod. For that, we are going to use config map and secrets concept in the Kubernetes. Okay, it is damn sure interview question. How do you maintain the database properties of your application? Are you going to hard code them in the project? No. So the database properties we are going to maintain by using config map and secrets concept in the Kubernetes. So we will talk more about that config map and secrets in the tomorrow or day after tomorrow session. Next one, there is a concept called ingress controller is available in the Kubernetes. So to divert or to route outside, to route incoming traffic, to particular service in cluster. Whatever the traffic is coming to the cluster, the ingress controller will act as a front controller. Ingress controller will check what request is coming. This request should go to which service in the Kubernetes, because we don't expose the services as node port services or load balancer. We don't give our service access to the public. When the public sends some request to that request should be routed to particular service in the cluster. The routing part will be taken care by ingress controller in the Kubernetes. So front-end pods are running, back-end pods are running, database pods are running. Whenever a request comes from outside, when the public people are accessing the URL, that request should go to which is service in the cluster. That routing part will be taken care by ingress controller in the Kubernetes. Are you guys getting my point? What is ingress controller in the Kubernetes? To route incoming traffic to particular service in the cluster. Liveness and readiness probes concept is available to check pod's health to give the traffic. Okay, so whenever we configure readiness prop for the pod, Kubernetes cluster directly will not give the traffic to the pod. So when the pod has to serve the traffic, that pod should pass the readiness check. Readiness is used to determine when the pod is ready to accept the traffic or not. And the liveness is used to check whether the pod is live or not. Readiness means is that pod is ready to take the traffic or not. This is one check, guys. Readiness probe check will be there on the pod. I will configure readiness check on the pod. That means that pod should pass the readiness check. Then only it is, I will understand that it is ready to take the traffic. Liveness check I will configure on the pod. It is used to check whether pod is alive or not. To check pod is ready and pod is live. To check pod is ready and pod is alive, we are going to use this readiness and liveness. So when we want to give the traffic to the pod, that pod should be ready, that pod should be alive. Then only those pods will take the traffic. Otherwise, the pods will not take the traffic. That request will be given to another pod. There are 2 pods available. So if the pod is ready and if pod is alive and if the pod is ready, then only they will accept the request, right? Before giving the request to that pod, control plane will receive the request. Control plane will give the request to particular pod. Before giving the request to the particular pod, we need to check is that pod is alive or not? Is that pod is ready or not? So if these checks are passed, then only the traffic will go to that particular pod. Otherwise, traffic will not go to that particular pod. So we need to configure these checks on the pod. If a pod is passed with these checks, then only the pod will accept the traffic, will process the request. Otherwise, the request will go to another pod. Daemon set, stateful set, values, config map and secret, ingress controller, readiness and liveness concept is available. Daemon set is a resource which is used to create the pod in each worker node in the cluster. Stateful set is also a resource which is used to create the pods with some storage. Okay, and PVC will provide the storage required for the stateful set. Config map and secrets, these concepts are used to supply environment variables to the pods. Like for example, database properties I want to supply dynamically. For my application, I want to supply some values dynamically at the time of deployment. Then we will use config map and secrets concept. What is ingress controller? Ingress controller is used to route the incoming traffic to the particular service in the Kubernetes cluster. Readiness liveness props are used to check whether the pod is ready and whether the pod is alive or not. These are the 6 topics we are left in the Kubernetes, guys. Daemon set is very small already. If you deploy EFK stack, that means daemon set is completed. Fluent D. So daemon set is a resource which is used to create the pod in every worker node. Normal applications we don't deploy by using daemon set. Log collector, metrics API, storage services, these kind of pods we will deploy by using daemon set. When you want to deploy normal application, Java application, Python application, they will be deployed by using deployment resource. When you want to deploy database in the Kubernetes cluster, then stateful set with PVC is recommended. When you are using database properties we will configure by using config map and secret. When we have multiple services in the cluster, to route the traffic, we are going to use ingress controller. Kubernetes is.
But ingress controllers are incoming traffic or outgoing traffic? Like
only incoming, sir. Incoming. I have mentioned that. To route incoming traffic to the particular service in the cluster. So whoever is accessing our URLs, those URL requests based on the path it will identify. This URL should belong to which service in the cluster.
Okay. So then reverse for me, what will go like?
Not for outgoing, only for incoming.
Quick question, sir. Are we gonna have class tomorrow?
Yes, we have.
Sir, for all these resources, we are going to create the YAML files, right?
Yes.
Sir, can you cover this node drain and node drain?
Taints. Yes, taints concept. There is one more concept. Is there node taints concept? Is there?
Node drain and
node taints. Tainting. Tainting in the Kubernetes. Right?
Yes, sir.
What is the purpose of node taint? So by using tainting, you can decide your pod should be created on which worker node. Okay. Using tainting concept, taints and tolerations, guys. Basically, this concept is called as taints and tolerations.
Sir, in worker nodes, how many pods can we create?
We can create any number, sir. There is no limit.
Sir, can you give an example for a daemon set? I have confused.
Sir, daemon set ante na pod anedi prati worker node lo create avvali. Daniki mana daemon set vaadtam. Adi worker node unte every prati worker node lo oka pod create avvali. Daniki daemon set.
So when we use daemon set, then it is compulsory that it has to create in each worker node the pod.
It's mandatory.
Okay.
Okay. What is the purpose of taints and tolerations in the Kubernetes? Any idea? To decide in which worker node
it is used to like resource allocation in the cluster.
Pod should be created. In general, do we have any control? My pod should be created on the which worker node? Do we have any control on that pod? Do we have any control on that pod?
No.
My pod should be created on the first worker node or second worker node? No, right? If you want to do that control, then we can use a concept called taints and tolerations. So by using taints and tolerations, we can decide in which worker node our pod should be created. Okay,
sir,
good guys.
What is node drain? Node drain.
No, I did not hear that, sir. Can you comment on this? I will go through that once.
Node drain.
Node?
Drain, sir. Drain. D-R-A-I-N.
Sir, he's telling about drain. D-R-A-I-N. Draining.
Drain.
Means
draining
when we want the node to be do maintenance, we do the draining. No, that is his ask.
Node drain. No, sir. I need to check it once.
Okay, sir.
Sir, what about pod affinity and node affinity?
We'll discuss that, sir. Affinities. Okay, good. Fine, guys. With this, I'm stopping on this. So tomorrow we'll continue and we will do practicals on these topics.
Sir, when we start AWS?
I will update you. So currently Python is going on now. So once it is done, we will start the AWS.
Okay. Sir, hello. One more question. Sir, you say before 2 days before about HA method, high availability method.
HA, high availability cluster.
Yeah.
Whatever the cluster EKS we are using, that is a HA cluster only.
So it's used for switch the traffic, right?
Yes. In the real-time production, same cluster will be used.
So could you please show how to it in practical?
Sir, whatever the cluster we are using, that is HA cluster only. Na?
Okay.
That is practical cluster we are doing.
No, sir.
cluster.
After while blue green deployment, need to switch a traffic, right?
HA proxy you are asking?
Yes.
Okay, HA proxy. Okay, sure. Okay, sir.
Show me sir about practically.
Okay.
Thank you, sir.
Thank you, guys. Good night.
Sir, one more question. Like, if our pod is suppose in a node 1, our application is in a node 1 pod, and what is the use of use of the daemon set to deploy our logs in the every pods, but our application is the one pod.
Sir,
only.
in real time, nobody will create only one pod for the application, sir. We don't create only one pod for the application, right? Definitely we'll create multiple pods for the application. Those pods will be available on the multiple worker nodes. If you create only one pod for your application, then how you achieve high availability? If that pod is deleted, one pod cannot serve the entire traffic, right?
Right.
Yeah, definitely we'll create multiple pods, and those multiple pods will be available on the multiple worker nodes, not on single worker node.
Okay, means we have to replicate in real life. We have to replicate our application pods.
Yes, right.
Okay, yeah.
Sir, your JRPT trainings from 7 a.m. onwards, or?
Yes, sir. 7 a.m.
7 a.m. daily, right?
Yes.
And what is the course fees for that?
9,000.
For us, any discount or that is 9,000?
Yeah, sir.
Yeah, sure. Tomorrow you can attend that class.
Sir, like, are you taking the Spring Boot and microservice from scratch for that?
That is different batch, sir. Project batch is different. Spring Boot microservice is different, sir.
Like, who is taking that, sir?
Both batches I will only take. Those are different batches.
Okay, it is not a part of this Java full real-time project.
No.
Okay.
So we can attend freely, right, Ashok? We need to register now, or?
Sorry?
We can attend freely, or we need to register now?
Those are two separate paid courses.
No, JRPT I'm asking.
JRPT, huh?
Yeah, JRPT is a paid course.
Sir, that Spring Boot and microservice, is it happening started, or
It's not started, sir. From 10th July it is going to start.
Okay, you will be taking that class.
Yeah.
Okay.
Okay.
Thank you.